So here we want to estimate the difference between the mean time taken by or taken to drive between the two branches of a company via route A and route B. So we want to estimate the difference by constructing a confidence interval. Now we shall have to assume that, or rather let's hope the sample was collected in a way that these are independent samples and also these are simple random samples. And here the sample sizes are large, but remember, in order to use our calculations, we need to have an assumption that the samples come from a normally distributed population. But here the sample sizes are large, so it would not matter very much. Now, the standard deviation that we are using is from sample data. So when we use our calculator for the interval, we'll go stat tests. So we are going to use a two sample t interval because we do not know the population standard deviation. And the other thing is that we are using the stats option because we are using the summary statistics rather than using the raw data. So here the x1 bar, that means the mean of the population 1, is 93 minutes and standard deviation is 15, and the sample size here is how much? 51. And for the second sample we have the mean as 81 minutes, standard deviation as 21, and the sample size is 62. Okay, so this is what we got here. So now that we have entered this information, we will go ahead, and our confidence level is 99%. So let's change it to 0.99. Now it's saying whether we want to use the pooled test or non-pooled. Now if we wanted to use the pooled test, we have to have another assumption. Okay, and that assumption is that the standard deviations of the two populations are the same, and this test is not very robust against the violation of that assumption. So we are just going to choose no, and in this particular course just choose no for pooled. Okay, all right, and then we will just ask it to calculate the confidence interval for. So let's ask it to calculate, and then here we have the interval that ranges from like about 3 minutes to about 21 minutes. Okay, so a 99% confidence interval for the difference between the mean times via the two routes would be between 3.1 minutes to 20.9 minutes. All right. So here we have this person Ron who want to conduct a hypothesis test to test whether the flowers treated by a fertilizer would be taller than the flowers that are left untreated. Okay, so what Ron has to do is, so he has to test the hypothesis that if mu1 is the mean height of the treated flower plants and mu2 is the mean height of the untreated, I should have written untreated here, I'm sorry, so untreated flower plants. Okay, then our null is what? Mu1 is equal to mu2, and the alternative is mu1 is greater than mu2. Okay, so now you have to collect the data. Okay, so now to collect the data, what he does is that he divides 8 plants of such flowers randomly into two groups of 40, and then plants them in identical but separate lots so that we can treat them as independent simple random samples, okay, and then say the results are that the mean height of the treated plants is this, and untreated are 8.7 inches, and these are the standard deviations. Okay, so in this case, what we are going to do, instead of doing the interval, we are looking at two sample t-tests, and t-test, because we know, because our standard deviation is being calculated from the samples, right? And again, we are looking at the summary stats. So 14.5 is the mean height of the treated plants, all right, and their standard deviation is how much? 1.96 inches. How many of them are there? We have 40 each, so 40, and then we got 8.7, then 2.12 inches, right? And sample size is still 40, okay? But our alternative here is what? Or the alternative is greater than, that is mu1 is greater than mu2. So let's choose that alternative, okay? And then we are saying no to pooled. Remember that? So we have no for pooled, and then we will do what? We will ask it to calculate the numbers for us, okay? So when we do that, what we find is, well, we find that the p-value here is, yeah, that's really small p-value. You can see it's 6.13 times what? Times e to the negative, time 10 to the negative 21 rather. So what we got from our calculator output, that the value is, what the value was, I'm sorry. Yeah, let me get that back for you. It's, so our alternative is mu1 is greater than mu2, and the p-value is like 6.14 times 10 to the power negative 21, right? Negative 21, and that power goes on the top. Sorry about the script here. And that is much less than 0.01, the level of significance that we took, okay? So just as in the one sample case, our p-value is less than the level of significance. So what do? We reject the null and conclude that the treatment group is showing a taller height, all right? Now let us take up an example of the matched pair design for comparing two population means, okay? So in this case, what we want to see is that, say there is a faculty training program which will help them improve the level of, or their student evaluation or the student perception of the faculty score. So what a university say does is that it selects 31 faculty members from, you know, hundreds of their adjunct faculty and send them to this training program. And then what is the objective? That the mean of the difference, okay, of the mean after these scores and mean before these scores is going to be 0. I mean, that's what the null would be, because null is no difference here. And the alternative is what? That the mean is going to improve if they do it like that. So improve means it's going to be greater than 0. So that's the alternative here, right? and we can write this as symbolically as say the null is mu sub d is 0 and the alternative is mu sub d is greater than 0. Okay. So say here are their data, and I just rewrote the hypothesis that I wrote in the previous slide, that we want to test whether the mean of the difference is, so the difference of the means is 0 versus the difference is positive. Now notice this, here we don't have independent samples anymore. All right, so the two samples are dependent because they are each matched on the same faculty members. So here we are looking at these differences, and so we have how many? 31 subjects here, and even though the sample size is not that small, it may not hurt to look at a box plot of this, and you all know how to make a. So here is a box plot of the differences that I made for you, and you can see there are no strong skewness here. Now we can do it two ways. One is we can enter the raw data, or let me just take you through a little different route in which I'm giving you the summary statistics. Okay. So here we are given the summary statistics of all the three variables, and I just want us to recognize that the values that we shall use here are the values for this variable, because often we will have this, that if we are looking at a computer output, we will have a lot more information than we really need. So we are simply going to need the mean of these differences and the standard deviation of the differences, and then just going to use one sample t on this variable differences. Okay, so let's just quickly finish that. So we will get our calculator, and this time what we are going to do is we are going to take one sample t-test, right? Because all the standard deviations that we have here, they are from sample, and we are still looking at it through summary statistics. And now this value that we are looking at is the mu d, that the mean of the differences, and we are assuming that to be 0. The mean difference is 0.5926, standard deviation is 0.3186. Okay, and the sample size is 31, and our alternative is greater than, so we shall let it stay greater than. Okay, and then we go to calculate, and then here is the p-value. It's again a very small p-values, 0.00. I have 10 to the negative 11, so they're like 0.10 zeros followed by a 1, so it's approximately 0. So what shall we conclude? That the null is rejected, and we have an evidence for the difference. So now let's take our third example, in which a person would like to test if the mean diastolic blood pressure is different at work for that person than the mean diastolic blood pressure at vacation. So that means what the person is trying to do is test this null hypothesis, mu1 equals mu2 versus mu1 is not equal to mu2. Okay, now in this case, I mean, first person has to collect data. Now this is not a matched pair, because the person will take the blood pressure at randomly selected times at work, and then also at randomly selected times during the vacation. So what are we testing is, we are testing the null of equal to versus alternative not equal to, and then say they got this data for the blood pressure reading at work, at work versus vacation. Now we are not given the summary statistics here, so I want to show you that we can handle it by using our graphing calculator. So what we can do is say L1 is the column of work and L2 is the column for vacation. So we can go ahead and enter all these data in here. So let's do that, and I'm just going to bring it back to you very quickly after completing it. So here I have entered the entire data. So now, and notice this, that I just entered the data as it is. I did not create a frequency column. That is 94 is here, then 98 came in twice, but I typed it in twice, and that would show up in our data entry here. So what we are going to do is we are doing two sample t-test here. And now instead of choosing a stat, we are going to choose data. All right. And we will say that L1 is our first list of data. Then for the frequency, we'll say each number has frequency 1. And in this case, our alternative is what? That's not equal to. Okay. So we are saying no to pooled, and then we say calculate. So in this case, what happens? Your p-value is 0.3316, and going with our typical criteria here, we did not have any level of significance, but 33% in our routine is kind of not very small p-value, so we will not reject the null, and we shall conclude that based on this data, the mean is the same at the two locations, okay, or in the two situations, whether the subject is at work or the subject is on vacation. Okay, so in this example, we are going to now test for two population proportions. So in this case, the example that we have is we want to see whether the proportion of people with insomnia among the users of a medication is higher than the proportion with insomnia among the users of placebo, that is a dummy medication, right? So what are we doing here is that we are testing. So if P1, so we are testing this null versus this alternative, where P1 is the proportion of all the people in the medication group who report insomnia, and P2 is the proportion of all the people in the placebo group who report insomnia, and our null is the two proportions are the same, and alternative is that medication group has a higher incidence of insomnia. So if we look at the data, so in this case, the subjects are divided into these two groups. One is given medication, the other one is given placebo, and 17 out of 121 report insomnia in the medication group, and 11 out of 122 in the placebo group. And we have to test whether this proportion is significantly higher than the proportion in the placebo group. So in this case, we'll go to stat, go to tests, and now we are going to use two proportion z test. Okay, all right. So here we have two proportion z test, and we got x1, that is our group 1 is the medication group. So I have 17 here. Then how many total? 121. Then in x2, what I have is 11, and what is my total? 122, right? And my alternative is that this P1 is greater than P2. So we will ask it to calculate, and my p-value comes out to be about 0.22. So in this case, again, we are not rejecting the null, all right, that we still don't have significant evidence, or we do not have significant evidence that the medication group has a higher incidence of insomnia, okay? Now let's visit the last technique of today. That is, here we want to estimate the difference in proportion between two populations regarding a certain attribute. For instance, say there is a politician whose approval rating is 79% in one state out of these based on the sample of these many a sample of these many citizens, and in the state another state, say V, it's 43%, and we would like to create a confidence interval for the difference between the population proportions. That these are the, I mean, these could be variable. You pick a sample of another sample of 438, your percentage of proportion here will be different. So what we do in this case is we'll just go back and we will go to stat, and here we want to proportion z interval, right? Okay, so there we have one prop z interval, here we have two proportion z interval. Now here we are given the percentages in the information, right? But here it's asking for number. So what we have to do is we have to give it 79% of 438. So let's quickly get those numbers. Okay, so 79% of 438, that is about 346, and then we need 43% of how many? 460. Oops, sorry about that. Okay, so that's about 198. So let me try to remember it, otherwise I'll forget. Okay, so here we go. So what we have is that we got, so we'll go to stat, we will go to proportion z interval. Okay, all right, here we go. So we got 346 in the state M out of how many? Out of 438. Okay, and about 198 out of how many? 460, and our confidence level is 95%, and then we will just ask it to calculate it, and here is our confidence interval. That is the interval for difference in proportion is 0.30 to 0.42, or the difference in percentages is anywhere between 30% to about 42%. Okay.